Today's lecture is about conditionals. To introduce the topic of conditionals, let me start by telling you a story. Imagine that my next door neighbor, Travis, has been breaking into my house while I'm gone and stealing my stuff. I get suspicious about this, so I hire a private investigator to follow Travis everywhere he goes. He follows Travis to his house at night, he follows Travis out of his house in the morning, and he follows Travis everywhere he goes during the day. Now, you might ask me, is the private investigator right now having lunch at that Cuban restaurant, New Havana? I'll say, well, if Travis is having lunch there, then the private investigator is having lunch there. Notice that we just used the words if and then to connect two propositions. We connected the proposition, Travis is eating lunch at New Havana, with the proposition, the private investigator is eating lunch at New Havana, by saying, if Travis is eating lunch at New Havana, then the private investigator is eating lunch at New Havana. Thus, we built a new proposition out of those first two propositions, connecting them with the words if and then. So, the words if and then together work as a propositional connective. Let's consider how well you understand the propositional connective if-then. Suppose you have four cards. This card has the number 3 on it, this card has the number 8 on it, this card has the letter A on it, and this card has the letter X on it. Now consider this claim. If a card has a vowel on one side, then it has an even number on the other side. Now I ask you, which card or cards would you need to flip over in order to verify that this claim is true? Well, the right answer is this card with the letter A on it and this card with the number 3 on it. Now, statistics tell me that 70% of you answered that you would need to flip over the card with the number 8 on it. And for that reason, you need to learn something about conditionals. But do they work as a truth-functional connective? Well, remember, they do work as a truth-functional connective only if the truth value of the proposition that you use them to build depends solely on the truth values of the propositions that you use them to connect. So, does the truth value of if Travis is eating lunch at New Havana, then the private investigator is eating lunch at New Havana depend solely on the truth value of Travis is eating lunch at New Havana and on the truth value of the private investigator is eating lunch at New Havana? Well, let's see. We can try to construct a truth table and see if the truth value of the whole proposition depends solely on the truth values of its two ingredient propositions. So, to see whether the propositional connective if-then is a truth-functional connective or not, let's see if we can do a truth table for it. So, we consider 4 possible situations. In one situation, it's true that Travis is at New Havana and true that the private eye is at New Havana. In the second possible situation, it's true that Travis is at New Havana, but false that the private eye is at New Havana. In the third, it's false that Travis is at New Havana, but true that the private eye is at New Havana. And in the fourth possible situation, it's false that Travis is at New Havana, and also false that the private eye is at New Havana. Now, what can we say about the situations in which it's true that if Travis is at New Havana, then the private eye is at New Havana? Well, one thing that's clear is that if it's true that Travis is at New Havana, but it's false that the private eye is at New Havana, then this proposition right here is going to be false. So in the situation represented on this second line, the proposition, if Travis is at New Havana, then the private eye is at New Havana, is going to be false. But what about the other situations? Suppose Travis is at New Havana and the private eye is at New Havana. Well, if they're both at New Havana, then it seems pretty clear that the statement, if Travis is at New Havana, then the private eye is at New Havana, is going to turn out to be true. But you might worry, wait a second, just because the first proposition is true and the second proposition is true, does that mean that combining them with a propositional connective if-then results in a true proposition? You might think, not necessarily. Because consider the following example. Consider this example. If 2 plus 2 equals 4, then Pierre is the capital of South Dakota. Now what I've done there is used the propositional connective if-then to connect two propositions, both of which are true. It's true that 2 plus 2 equals 4, and it's also true that Pierre is the capital of South Dakota. But just because I've used the propositional connective if-then to connect two propositions that are true, does that mean that the resulting proposition, if 2 plus 2 equals 4, then Pierre is the capital of South Dakota, that the resulting proposition is true? Well, it's not clear. If I tell you, if 2 plus 2 equals 4, then Pierre is the capital of South Dakota, do you want to say that's true or that's false? Well, it's not obviously true, but it's also not obviously false. It's just kind of baffling. But just because this proposition is baffling doesn't mean it's not true. Look, it's baffling that Pierre is the capital of South Dakota, but that doesn't mean it's not true. As it happens, it is true that Pierre is the capital of South Dakota, baffling as that might be. So, just because this proposition, if 2 plus 2 equals 4, then Pierre is the capital of South Dakota, just because that proposition is baffling, doesn't mean that it's not true. So is it true? Let's find out. So suppose you have two propositions, P and Q. P could be the proposition, Travis is at New Havana, and Q could be the proposition, the private eye is at New Havana. Well, let's suppose that the negation of P and the negation of Q is true. Suppose that for a moment. What follows? Well, what follows is that P and the negation of Q, that proposition right there, is false. Remember, because every proposition has the truth value opposite the truth value of its negation. So if the negation of that proposition is true, then that proposition itself must be false. Now, if that proposition is false, then what does that tell us? Well, it tells us that P and not Q cannot both be true. So if P is true, then not Q has got to be false. Right? If P and not Q were both true, then this conjunction would be true, not false. So if P is true, then not Q has got to be false. But if not Q is false, then Q is true. Because Q has got to have the opposite truth value of not Q. So, what can we conclude? We can conclude that if the negation of P and not Q is true, then if P is true, then Q is true. If this proposition right here is true, then this proposition right here is true. But notice, we can conclude something else. Suppose that if P is true, then Q is true. What follows from that? Well, one thing that follows from it is that you can't have it be the case that P ends up being true but Q is false. Let's write that down. It can't be the case, it's not the case, that P is true and Q is false. In other words, not Q is true. It can't be the case that P is true and that not Q is true. But that's just what we started with. So here's what we've shown. We've shown that if the negation of P and not Q is true, then it follows that if P is true, then Q is true. And we've also shown that if the proposition, if P is true, then Q is true, if that proposition is true, then it follows that the negation of P and not Q is going to be true. So, this proposition implies this one, and this one implies this one. Which means that whenever this one is true, this one has got to be true, and whenever this one is true, this one has got to be true. So in other words, they're true in all the same situations. So, if there's a truth table for this, it's going to be the very same as the truth table for this. But is there a truth table for this? Let's figure out whether there's a truth table for this. So remember, if we're going to do the truth table for this, we have to start by considering the four possible situations we have with the propositions P and Q. It could be true that P and true that Q, true that P and false that Q, false that P and true that Q, or false that P and false that Q. Okay, so those are our four possible situations. Well, consider the truth table for the negation of Q, for not Q. Well, that's going to be false whenever Q is true, and it's going to be true whenever Q is false. So that's the truth table for not Q. Now, how about the conjunction of P and not Q? That's only going to be true when P is true and not Q is true. In other words, in this situation. This is the only situation where P and not Q will be true. In every other situation, it'll be false. It'll be false wherever P is false, and it'll be false wherever not Q is false. Now, how about the negation of P and not Q? Well, the negation of P and not Q is going to be true whenever P and not Q is false, and it's going to be false whenever P and not Q is true. So, it's true here, true here, and true here. Now, does this truth table look familiar to you? Yeah, you remember. It's the same as the truth table for not P or Q. The truth table that we constructed in last lecture. So remember, the negation of P and not Q is true in just those cases when if P then Q is true. These two propositions are going to be true or false in all the same situations. So, if there's a truth table for the negation of P and not Q, then there's going to be a truth table for if P then Q, and it's going to be the same truth table. So let's get back to our Travis example and see how to fill it out. So applying that discussion to this example, we can now say that whenever it's false that Travis is at New Havana, then no matter where the private eye is, it's going to be true that if Travis is at New Havana, then the private eye is at New Havana. So this is the truth table for if-then. And so if-then is a truth functional connective. I've just argued that in English the phrase if-then can work as a truth functional connective. But there are other phrases in English that can work in exactly the same way to express exactly the same truth functional connective. One such phrase is only if. If I say, If Travis is at New Havana, then the private eye is at New Havana. What I'm saying means the same thing as Travis is at New Havana only if the private eye is at New Havana. Those two propositions are going to be true under just the same circumstances. Another word that we can use in English to express the very same truth functional connective is just the word if. We could say the private eye is at New Havana if Travis is at New Havana. And that means the very same thing, and it expresses the very same proposition as if Travis is at New Havana, then the private eye is at New Havana. We're going to use a horseshoe to symbolize the truth functional connective if-then. Now we can use the truth table for if-then to show that a certain kind of inference, a kind of inference that we're going to call modus ponens, is always valid. Now a modus ponens inference is an inference that has two premises. The first premise has the form if P then Q. The second premise has the form P. In other words, the second premise just says that the first proposition in if P then Q is true. And the conclusion is Q. So the first premise tells us that we're in a situation in which P horseshoe Q is true. So the first premise rules out this situation right here. It tells us that this situation right here isn't the actual situation. The second premise tells us that we're in a situation in which P is true. So the second premise rules out this situation where P is false, and it rules out this situation where P is false. So the two premises together rule out all three of these possible situations. In other words, according to the premise P horseshoe Q and the premise P together, the only possible situation is this one. But notice, if this is the only possible situation, then Q has got to be true, because Q is true in this situation. So, whenever we have an inference, the first premise of which is P horseshoe Q, the second premise of which is P, we know we can draw a conclusion to the effect that Q, and that inference is going to be valid. There's no possible way for the two premises of that inference to be true while the conclusion is false. And that's why modus ponens is a valid inference. There's another kind of inference called modus tollens. A modus tollens inference is one in which the first premise says, if P then Q. The second premise says, not Q. And the conclusion is, not P. Now we can use the truth table for if-then to show that a modus tollens inference is always valid. Here's how. In order to see that modus tollens is a valid form of inference, we need a slightly more extensive truth table than we used to show that modus ponens is a valid form of inference. So again, remember we have four possible situations. P and Q are both true, P is true and Q is false, P is false and Q is true, or P and Q are both false. Now, when P and Q are both true, then P horseshoe Q is true. When P is true and Q is false, then P horseshoe Q is false. And whenever P is false, then P horseshoe Q is true. Now, the negation of Q is going to be false whenever Q is true and true whenever Q is false. And the negation of P is going to be false whenever P is true and true whenever P is false. Now, using this truth table, we can prove that modus tollens is a valid form of inference. Remember, the first premise of a modus tollens inference is if P then Q, P horseshoe Q. So that first premise rules out the possible situation where P horseshoe Q is false. So we can rule out that situation right here. The second premise of a modus tollens inference says not Q, and that rules out the situation in which not Q is false. There are two such situations. There's this one. That's one where not Q is false. And there's this one where not Q is false. So the two premises of a modus tollens inference rule out these three possible situations, and they leave the only possible situation as this one. This situation where P is false, Q is false, P horseshoe Q is true, not Q is true, and not P is true. But since that's the only possible situation left open by the premises of a modus tollens inference, and since that's a situation in which not P is true, the conclusion of a modus tollens inference, namely not P, is going to have to be true whenever the premises of that inference are true. So every modus tollens inference is valid. The truth functional connective if-then is what we call a conditional. Each conditional has two propositions that it connects. A proposition that comes before the horseshoe, right after the if part. That's called the antecedent. And then there's the proposition that comes after the horseshoe, right after the then part. That's called the consequent. So every conditional has an antecedent and a consequent. And the conditional is true whenever the antecedent is false, or when the antecedent is true and the consequent is also true. The only time a conditional is false is when the antecedent is true and the consequent is false. Finally, I want to wrap up by introducing another kind of truth functional connective that we call the biconditional. The biconditional is really a conjunction of two conditionals. It's the conjunction of if P then Q and if Q then P. What the biconditional says is two propositions, P and Q, have exactly the same truth value. P is true if and only if Q is true. We're going to use these three horizontal lines to symbolize the biconditional. Now, here's the truth table for the biconditional. Remember, we have four possible situations. P and Q are both true, P is true and Q is false, P is false and Q is true, or P and Q are both false. Well, P biconditional Q is true whenever P and Q have the same truth value. So, P biconditional Q is going to be true in this situation when P and Q are both true, and it's going to be true in this situation where P and Q are both false. But in these two situations, the propositions P and Q have different truth values. So P biconditional Q is going to be false in both of those two situations. In English, we express the biconditional using the phrase if and only if. That concludes our lectures on truth functional connectives and propositional logic. Next week, we'll talk about categorical logic.